Modern atomic theory. Have you ever wondered what produces the different colors in a fireworks display? Certain compounds will produce certain colors of light when they are heated. Compounds containing the element strontium produce red light. Compounds containing barium produce green light. Bohr's model of the atom. What can happen to electrons when atoms gain or lose energy? As did Rutherford's atomic model, Bohr's atomic model had a nucleus surrounded by a large volume of space. But Bohr's model focused on the electrons and their arrangement. In Bohr's model, electrons move with constant speed in fixed orbits around the nucleus, like planets around the sun. Each electron in an atom has a specific amount of energy. Energy levels. When an atom gains or loses energy, the energy of an electron can change. The possible energies that electrons in an atom can have are called energy levels. An electron cannot exist between energy levels. An electron in an atom can move from one energy level to another when the atom gains or loses energy. An analogy for energy levels of electrons is a staircase. The landing at the bottom of the staircase is the lowest level. Each step up represents a higher energy level. The step height represents an energy difference between the levels. You can only move in whole numbers of stairs. An electron may move up or down two or more energy levels if it gains or loses the right amount of energy. The size of the jump between energy levels determines the amount of energy gained or lost. No two elements have the same set of energy levels. Scientists can measure the energy gained when electrons absorb energy and move to a higher energy level, or measure the energy released when the electron moves to a lower energy level. Light is a form of energy that can be observed. The movement of electrons between energy levels explains the light you see when fireworks explode. Heat causes some electrons to move to higher energy levels. When those electrons move back to lower energy levels, they release energy. Some of that energy is released as visible light. Different elements emit different colors of light because no two elements have the same set of energy levels. What model do scientists use to describe how electrons behave in atoms? An electron cloud is a visual model of the most likely locations for electrons in an atom. Scientists use the electron cloud model to describe the possible locations of electrons around the nucleus. Bohr's model was improved as scientists made further discoveries. Bohr correctly assigned energy levels to electrons, but electrons do not move like planets in a solar system. Today, scientists use probability when trying to predict the locations and motions of electrons in atoms. An electron cloud is a visual model of the most likely locations for electrons in an atom. The electron cloud model replaced Bohr's vision of electrons moving in predictable paths. The nucleus containing protons and neutrons, the electron cloud being a visual model of the probable locations of electrons in an atom. The probability of finding an electron is higher in the denser regions of the electron cloud. The photographs below provide an analogy for an electron cloud. When the propeller of an airplane is at rest, such as the picture on the left, you can see the location of the blades. When the propeller is moving, such as the photograph on the right, you see only a blur that is similar to a drawing of an electron cloud. What model do scientists use to describe how electrons behave in atoms? An orbital is a region of space around the nucleus where an electron is likely to be found. The electron cloud represents all the orbitals in an atom. An electron cloud is a good approximation of how electrons behave in their orbitals. For an analogy to the concept of an orbital, imagine a map of your school. Mark your exact location with a dot once every 10 minutes over a period of 1 week. The dots on your map are a model of your orbital. They describe your most likely locations. The places you visit the most would have the highest concentration of dots. The places you visit the least would have the lowest concentration of dots. The level in which an electron has the least energy the lowest energy level, has only one orbital. Higher energy levels have more than one orbital. What is the most stable configuration of electrons in an atom? An electron configuration is the arrangement of electrons in the orbitals of an atom. When all the electrons in an atom have the lowest possible energies, the atom is said to be in its ground state. The most stable electron configuration is the one in which the electrons are in orbitals with the lowest possible energies. A lithium atom has 3 electrons. In the ground state, 2 of the lithium electrons are in the orbital of the first energy level. The third electron is in an orbital of the second energy level. If a lithium atom absorbs enough energy, one of its electrons can move to an orbital with a higher energy. This configuration is referred to as an excited state. An excited state is less stable than the ground state. Eventually, the electron that was promoted to a higher energy level loses energy, and the atom returns to the ground state. The ground state of a person is on the floor. A gymnast on a balance beam is like an atom, in an excited state, not very stable. When she dismounts, the gymnast will return to a lower, more stable energy level. Assessment questions. Number 1. According to Bohr's model of the atom, which of the following can happen when an atom gains energy? A. An atom returns to its ground state. B. A neutron can be changed into a proton. C. A proton can move to a higher energy level. Or D. An electron can move to a higher energy level. The answer is D. An electron can move to a higher energy level. Assessment question 2. How does the modern atomic theory describe the location of electrons in an atom? Is it A. Electrons move randomly in space around the nucleus? Or B. Electrons can be described as a cloud based on probable locations? Or C. Electrons orbit the nucleus in the same way that planets orbit the sun? Or D. Electrons move in a spiral path if increasing distance from the nucleus? The answer is B. Electrons can be described as a cloud based on probable locations. Number 3. What is meant when an atom is said to be in its ground state? Is it A. There is no net charge on the atom? B. The number of protons equals the number of neutrons? C. The atom's electrons all have the lowest possible energies? Or D. It is the isotope with the least number of neutrons? The answer to this question is C. The atom's electrons all have the lowest possible energies. Thank you for listening and reading Chapter 4.3, Modern Atomic Theory.